An organization can describe its own friction perfectly and still have no idea how to fix it. Someone in finance says the forecast is always wrong. Someone in operations says the handoff between systems is broken. Someone in sales says the data lives in 3 places that never agree. These are accurate complaints. None of them are specifications. That gap between naming a problem and building something that solves it is where engineering begins. This is the Opportunity Atlas, and this is the companion episode to the Opportunity Tree. If you have not seen that one, start there. It maps friction from the business side. Here we climb the same tree from the engineering side and ask a different question. Not where does friction live, but what does it actually take to build a solution? Start with the raw complaint. The forecast is always wrong. An engineer does not respond to that sentence directly. The engineer asks what data currently feeds the forecast, where it lives, how often it updates, and why the current process cannot use it. That is data engineering. Unglamorous, foundational, and usually the actual bottleneck, even when everyone assumes the problem is the forecasting model itself. Once the data is trustworthy, the next layer is feature engineering. Turning raw numbers into signals that actually predict something. Past sales alone rarely explain future demand. Seasonality, promotions, local events, competitor activity, these get engineered into inputs a model can use. This step is where a surprising amount of real work hides. It rarely shows up in the original business complaint at all. Only after that does machine learning enter the picture. A model trained on well-engineered features can forecast demand, flag anomalies, or route a request to the right team. But the model is the smallest part of the system by volume of work. Most of an AI project is the pipeline that feeds it, not the model itself. This is one of the more persistent misunderstandings between business and engineering. Leadership hears machine learning and pictures the model. Engineers know the model is maybe 10% of the effort. From a business perspective, this matters because it changes how a project should be scoped and estimated. A request that sounds simple, just make the forecast better, may actually require weeks of data engineering before anyone touches a model. Naming that early prevents a lot of frustration later. From an opportunity perspective, each of these layers, data engineering, feature engineering, model building, deployment, is a distinct capability. Distinct capabilities mean distinct people, distinct skill sets, distinct hiring or contracting decisions. The business side sees one problem. The engineering side sees a stack of specialized work, each layer depending on the one beneath it. None of this is offered as the only way to build these systems. It is one useful way to think about where effort actually goes versus where it appears to go from the outside. This has been the Opportunity Atlas viewed from the engineering side of the tree. Together with its companion episode, the two form one complete look at how friction becomes a solution, from the business complaint down to the working system. Next time we go deeper into one of these layers on its own.